All right, so we have discussed IPv4 in brief. Trust me, it's in brief, although I was planning to have just part one of IPv4, but it looks like it turned out to part one and part two. Now I'm going to move to what I'm going to call part three, which is IPv6, part three IPv6, and talk briefly about IPv6. IPv6, if there is anything that you need to know about about IPv4, you need to know the fact that IPv4 has been depleted and we don't have IP addresses anymore. And for years now, we have been trying to figure out what is new solutions to this problem. We, through this years of figuring out, we come out with so many solutions. We came out with NAT, we come out with PAT, we come out of VPN, CIDR, but none of those have really solved the problem. The only valid solution that scientists and engineers have come out with to solve the depletion of IPv4 is the birth of IPv6. All right, IPv6. So IPv6 came in to solve the problem that we had with IPv4. But there are certain problems right now. Some of you, if you go to now to your, if you have an ISP such as a Comcast, I can guarantee you that you're already using IPv6. I know all major phones in the US are using IPv6, though we did not completely convert it to IPv6 in the US. We are still using both IPv6 and IPv4, so we are what we call in transitions. Now, the problem is if you have companies, some companies are using IPv4, other companies are using IPv6. So how can we solve this communication problem? How can we solve the communication problem? Well, we have a temporary solution to this problem till we completely convert to IPv6. Some of the solution that we have something known as dual stack a router. It's a router that supports both IPv4 and IPv6. We have tunnel IPv6. When the router received IPv4, then tunnel, received IPv6, then inside, but outside it used IPv6. So it creates a tunnel and allow that traffic to go there. We have another thing known as translation, known as NAT64, which is again convert between IPv4 and IPv6. What are these three solutions? All these three solutions are temporary solutions, try to resolve the problem of having part of the internet in IPv4, the other part in IPv6. Now, let's look a little bit more details on IPv6, and you're going to notice some differences. First of all, unlike IPv4, IPv6 is not 2 to the power of 28 or 32. IPv6 is 2 to the power of 128 bits. 128 bits. So as a result, that problem that we had before, depletion of IP addresses, there's a good chance engineers have said we will not run into this problem again in the future. And the reason, 2 to the power of 28 will give you the zillions of the zillions of the zillions IP addresses. As a matter of fact, somebody said that IPv6 can give every atom of Earth another Earth an IP addresses. Now let's look quickly at IPv4. In IPv6, we don't use the word octet. IPv6 is 128. IPv6, every 4 bit is represented by a single hex decimal. I can just see every 4 bit. So every bit here, it's really stand for 4 bits. So instead of this 0, really, they're 4 zeros, 4 0 0 0. So they're really 16. 4 times 4, they're really 16, not relative. So every bit stands for 4 more bits, known as nibble. Right. In IPv6, we don't use the term octet, we use hexstat. So this is not an octet because it's not an 8-bit. This is an hexstat because it's a 16 bits. All right. And you can see here, every number, right? Every number stands for 4 more numbers. So here's how IPv6 look like. You can see here's an example of IPv6. It starts by 2001 colon. So unlike IPv4, when we have a dot, in IPv6 we don't have a dot. We don't have a decimal value. We have a hex decimal. and we have a colon between each hackstat, not an octet, hackstat. All right. Furthermore, the first rule, as you can see, when we have in 128-bit, one of the problems that we run into is how to write an IP address. It's very long. 128 is really long. So long gone the days when an IT tells somebody, oh, I want you to go and ping 192.168.1.1. You can't do that anymore, because now that number become hexadecimal, very lengthy, and you can't. As a matter of fact, we even have a problem writing them and assigning them. So scientists and engineers have come out with some sneaky way of assigning IPv6 or shortening IPv6. So what they tell us first, they're nothing but a set of rules. They say to reduce or compress IPv6, what you need to do, the first rule is to omit leading zeros in any hackstat. Let's pretend you have 000:000:000:000, 4 hackstat, they all have 0. A rule said you can omit all of them. You can remove all of them and use just 1 0 instead, and have a 2. You can use a 2 colon and make that, and as a result, you can shorten that. So watch this, for instance. So here you have 000:000:000. Watch how we omitted all the 3 zeros and we have 1 0 instead. So in this, we have omitted every single 3 zeros, so to make it a little bit shorter. That is one way. So omit all the leading zero. Then second rule is an omit all 0 segment. Let's pretend you have an IP address where you have the hackstat are all zeros. And I'll give an example with this one. Here we go. This one, for instance. Watch here. This is an IP address, IPv6, but watch how this hackstat is all 0, and this other hackstat is also all 0, and this hackstat also is all 0, and this hackstat is all 0. So look what we did. Scientists have said, first of all, it is possible you definitely can omit and remove this all zeros here, this hackstat, and represent them instead. Look, instead what we did, we represent them with 1 0 only. This is the first rule that we saw. So we did it here, and we did it also here. Now, the second rule said to further compress it, don't use this 0 at all. Just use colon. So whenever we see colon after each other, we know that we have completely omitted a hackstat that has all zeros. All right, the rule that you can see, so there is 1 here and there is 1 here. So you were able to, okay, but you can't do both. You can't, as you can see, you can't omit, you can use, you can replace it with colon here and replace it. You can only use it once. Here's another example. In here, I want you to pay attention. Look, double colon can replace any single contiguous word. For you can see over here, we have this an IP address. We have all zeros here, all zeros here, all zeros here, and all zeros, over here. So they're saying it is quite possible to remove all the leading zeros, so it becomes 0. This 4 zeros become 0. This other 0, 0, 0, 0. Right? It's clear. Now you can further compress it. You omitted, now you can compress it. By compressing, since you have 1, 2, 3, 4, 0. I'm sorry, 1, 2, 3, 4, 5, and 6. They're all zeros. You can omit all of them and just have colon 1. Means that you have omitted all the rest of the hackstat you're replacing. So as a result, you have shortened them. And as a matter of fact, if you guys remember, I said that 127.0.0.1 in IPv4 is used, is known as a loopback, and used to test connectivity. Well, guess what? A 0001 is the loopback in IPv6 and is used to also to test connectivities. All right. Similar to IPv4, IPv6 also has Unicast, different type of IP addresses. We have Unicast, we have multicast, but this is new. I want to show you that IPv6 does not have broadcast. IPv6 only have anycast. So let me repeat again. Yes, similar to IPv4, IPv6 has unicast, has multicast, but there is no broadcast in IPv4. There's only something known as Unicast. Just like IPv4, IPv6 is also divided into two parts. One part is known as 64, known as a prefix and network ID, and the other one known as an interface ID. You have 128, so 64-bit known as a network ID, and the other 64-bit known as the host IDs. Unicast addresses, right? And this is unicast addresses. This is again similar to IPv4. Unicast IP addresses are divided into four types of IP addresses. There's one known as global unicast, which is the most common used one, the only one that you need to know, as a matter of fact. And there's link local, and I mentioned earlier. And watch how : 1. This is a link loopback that we use to test connectivity. And there's unique local. The most common one that you need to really remember that we use today is what we call global unicast. Global unicast. All right. Now, there's a little difference. When you need to assign an IPv6 to a router, you don't do what we do in IPv4. You just do IP address space and 192.168.1.1 space 255.255.0. Before you can assign an IPv6 to a router, you really need to do what you need to do. You have to type IPv6 address. Then you assign an IP address. So please remember that. You can't use IP space address and assign an IPv6. You have to type IPv6 address, then the address that you need to assign. Can we assign a computer IP addresses? You bet we can assign a computer an IPv6, similar to the way we do it IPv4. Just it's a little bit lengthy. See, here's a computer that is using an IPv6 instead of an IPv4. So here is the IP address. Here is the here is the subnet mask. All right, and here is the default gateway over here. All right, similar to IPv4, yes, you can test connectivity. You can ping an IPv6 the same way you can ping an IPv4. As a matter of fact, you can see here, show IPv6 interface brief, and it shows you all the interfaces that have an IPv6. You can type show IP address, IPv6 route, shows you all the routing table, or ping, all right? So we troubleshoot IPv6 the same way you use IPv4. The only thing you have to remember, all you use the word IPv6 before the command, not IPv4 anymore. All right, CMP or what we call it, ICMP or ping is the most common command. It's a command that we use to troubleshoot communication between end devices, in the same way in IPv4 and the same way in IPv6. So you open up, you go to command line, type in CMD, command line comes, and you type ping space and the computer IP addresses that you want to ping. I kind of talked about this earlier, and I said that you can do ping 127.0.0.1, and you'll be pinging the TCP IP. I want you to understand in here, when you ping 127.0.0.1, the computer sends 4 packet, but this 4 packet, you don't leave the computer. Don't even touch the wire. They'll go from the application all the way down to the physical and turn back. And we use this command to test TCP IP stack. And by the way, you can do the same thing for IPv6 if you just type ping space : ::.1. And here you see that we have omitted and we have compressed the IP address instead of having all the hex stack, type in the complete IPv6. Testing ping, testing connectivity. You just need to do, if a computer in the same network and you type ping space, whatever the IP address is, when you do that, a computer, you send it 4 packet, that computer read all the packet and echo back to you, hey, I read all your packet, I can see you and can talk to you, everything looks fine. All right. Another command that we use to troubleshoot routers is known as Traceroute. Traceroute is used to troubleshoot communication between routers and also used to find how many routes between your computer and the remote computers. How many routes is between your computer and your remote computer. And you can open up your computer and do traceroute space or tracecert space www.google.com, and you need to find out how many routes between you and Google and the machine that is hosting Google site, and how long does the packet stay at each route. Sometimes using Traceroute or Traceroute, we find congestion and we find traffic in what you call it in the network. All right, so we are done with this chapter. I know we're supposed to have only two, but it's very complex and very lengthy, so we end up by having three three part instead of two part in what he calls. Let me see if we can review anything quickly. So quickly, what we talked about IPv4 addresses, and we said it's a 32-bit. It's 2 to the power of 32, and it's divided. It's expressed in decimal value, and it's expressed in octet, and we have 4 octet. And we said that IPv6 is 2 to the power of 32, and which is roughly give us 4 billion IP addresses. And I told you that we have depleted all those. We have publicly depleted all IP addresses, all IPv4s, and we don't have them anymore. So we come up with so many solutions trying to solve the problem of the depletion. But the only solution that really worked, and we started adapting it today, is by using IPv6. And it's similar to IPv4 in so many things. And I said that IPv6, the only difference is that IPv6, it's 2 to the power of 128, mean instead of 32, we have 128, which gives you roughly about the zillion of the zillion of the zillion IP addresses. There's no chance of running of those IP addresses any soon. Beside that, whenever you send an IP address to an IPv6 to a router, instead of using the command that we use for the IPv4, which is IP space address, you want to always include IPv6 before you do that. And I said the two most common commands that we use to test communication, TCP/IP communication, we use ping, which is an ICMP protocol, part of ICMP protocol, and we use Traceroute or Traceroute to test connectivity between a client and a local computer and remote computer. And I said a good example: you open up your terminal and type Traceroute space www.google.com, and it shows you all the stops that the packet made at every single router and how long did it take to reach the remote location. And I said that engineer use this command to find out congestion in certain routers, right? And a router become congested for so many reasons. One of them is misconfigured, or either misconfigured or is running into some kind of hardware problem or software problem. All right, that we're done with this chapter. Next part, we're going to move to the lab.